Hi, and welcome to one more in the series of Idea Collider, where I get to chat and have conversations with my favorite authors and my favorite people within the pharmaceutical industry, touching on subjects that are next to innovation or ways that we can have more of it within our space. On this conversation, I was so pleased to have Matt Ridley, who is one of my favorite authors, full stop. Matt's books have sold over 1 million copies, been translated into 31 languages, and won several awards. The two most recent are perhaps the two that I'd recommend diving into first. So, The Rational Optimist and The Evolution of Everything, which, coming from my background as in genetics, was just a wonderful jumping together of two of my favorite subjects. He writes a weekly column in the Times of London and writes regularly for the Wall Street Journal. And as Viscount Ridley was elected to the UK House of Lords in February 2013 and served on the Science and Technology Committee from 2014 to 17. In this conversation, we discuss his forthcoming book, How Innovation Works. And you'll understand it's a very short conversation, why I was so keen to have Matt to talk about it before publication. Hopefully we'll get a chance to do it again once you've had a chance to read the book. But for now, enjoy everything here. Matt Ridley, delighted to have you on Idea Collider. I've been a fan of yours for a while. Could you tell me, could you tell everyone else a little bit more about you and what the new book is about?
Yeah, my name is Matt Ridley, and I basically write books about science, technology, evolution, economics, and related areas. And I'm incredibly lucky to be able to do so, to satisfy my own curiosity and also tell the world about it. And my latest thing is to write a book about innovation itself. I've been dancing around the topic of innovation in previous books, but I think innovation is the really big theme of human history. It's the most important thing that distinguishes us from other animals is our ability to produce new combinations of atoms or bits in the digital sense that enable us to change the way the world works to our advantage. And it's kind of mysterious as to how we do that, why we do that, why we're the only species that do that, why we suddenly had a huge flurry of innovation starting 200 or 300 years ago and accelerating in most cases right up until now. And we don't really know what policies make it happen. And we don't really know what it is that you've got to do if you want to set out and produce an innovation. I think we can now conclude that innovation is a product in itself. It is something you can set out to make. Someone like Thomas Edison set up an innovation factory where the output was innovations, if you like. But we're not really quite sure whether you're going to be able to achieve your ends when you do that. So that's what motivated me to write about this and to try and understand, where it comes from and how it works in the world.
Mm. So, and that's so fascinating that because of its importance, I mean, especially at times like this, we have got a very poorly defined thing. And one thing that I've always been drawn to in your work has been the separation of invention and innovation, which I think is helpful. Could you tell us more about how you see those two things?
Yes, I think this is a very important distinction. I think, on the whole, when you hear people talking about innovation, they tend to veer into talking about invention, talking about the person who invented the steam engine or whatever. Whereas I think the more you look into the history of it, and my book does go into the history of a lot of innovations, the more you conclude that the really hard work is the turning of an idea into something practical, affordable, and reproducible. And it's Thomas Edison put it beautifully when he said that new ideas are 1% inspiration and 99% perspiration. And he actually tried 6,000 different types of plant material before he came up with the right kind of Japanese bamboo filaments, which would work inside a light bulb, for example. Or another example for me is vaccination, which is something that emerges out of the Ottoman Empire in the early 18th century into Western Europe, people like Lady Mary Wortley Montagu, who lived in Constantinople and discovered that people were defeating smallpox by giving mild strains of the virus to their children, which made them immune, and that this was an old practice that had been practiced for a long time inside the harems in Constantinople and might even have come from China originally. So no one is saying that she invented vaccination, but she came back to the UK and said, "This is amazing, this works, you should try it. The Prince of Wales should try it for his kids." And she proselytized it, and the mob was furious and said, "This is a dangerous practice. What on earth are you doing?" Like a lot of people say about innovations. So people like that are innovators, but they're not inventors, and that seems to me very important. Jeff Bezos is a very good example of an innovator, but you wouldn't really call him an inventor of much. He didn't invent the internet, and he didn't invent online retail. But he jolly well innovated it for the rest of us. So my book very much does make the distinction between coming up with an idea and turning it into something ubiquitous.
Yeah, and it's interesting because I think that kind of corruption of that idea has led to folks almost delegating the creative part of invention to the whole process, right? So that innovation is regarded as, you come up with a good idea and automatically it's going to, get to market, get to patients, within our industry.
Yes, and I think one of the problems is academics think it's that the downstream stuff is easy. All they've got to do is come up with the idea, and it'll turn into a business straight away. And of course, again and again, you find that good as your prototype is, it's not ready for prime time, and it needs a lot of work, and it's not actually going to catch on in various ways. And so I do think that it's important to understand the ecosystem around that. And of course, the UK is a good example of a country that's often pretty good at invention, but not terribly good at innovation.
Which is interesting. So if you think about the and you've written about the kind of cultures and the evolution of kind of ideas and cultures of developing things. What is it maybe that the UK has, or is it that certain organisations have that tend to lead to productive innovation within the of a good idea?
Well, it's hard to put your finger on what makes, say, Silicon Valley such a successful source of innovations, or what made Victorian Britain such a successful source of innovations. One obvious thing is freedom. The freedom to tinker with things, the freedom to experiment, the freedom to do trial and error. You didn't have to get permission to do stuff. It's surprising how rare that is in history. Another thing is money. That on the whole, these things happen in prosperous areas, not in desperate, impoverished areas, even though their need for innovation might be even greater, arguably. And a third thing is obviously open-mindedness. But on the whole, I argue that science is not the mother of innovation to the same degree that we tend to think it is. That we tend to be enthralled to a linear model of innovation where we start with an idea in philosophy, we then turn it into something practical, we then turn it into something ubiquitous. It very rarely works out that way. Quite often you get innovation in a technical sense, which then has to be explained by scientists as to what's going on. That innovation is the mother of science as much as the other way around. For example, the steam engine comes before the science of thermodynamics rather than the other way around. We can sort of see what the ingredients need to be to make a country into an innovative one. But it's not a top-down process. It's not something that can be ordained from above. You can't say, right, we're going to do our innovation in transport this decade, and we're going to do it in communication next decade. It doesn't work out that way. I'm fascinated by the way transport has changed so little in my lifetime. There are still Boeing 747s flying across the Atlantic, which went into service 51 years ago, whereas our computers from 51 years ago would look completely different. And my grandparents had the opposite experience. They saw incredible changes in transport and very little changes in communication and computers. So it's not, it isn't. It isn't the case that you can dictate which areas of life you're going to innovate in to anything like the degree that politicians would like it to be, I suspect.
Mm. So that kind of pull model versus a kind of evolution model is hard for the folks at the top to kind of get their heads around. If you were designing a company or an institution like the EU or the UK, with its kind of new opportunity, how do you reconcile that kind of need for more of what happens that's good with this kind of slightly diffuse input at the front end?
Yeah, it's not easy, and I think we tend to make the mistake of picking winners, saying this is the technology we're going to champion, and if you contrast the story of computer chips, particularly the Moore's law phenomenon, whereby computers improved at a very steady rate for 50 years or so in terms of miniaturization and in terms of cost reduction for a given quantity of computing power. And Gordon Moore spotted this very early, and he said that every 18 months we're going to double the amount of computing power you can buy for a certain amount of money. And that ought to have enabled us to jump ahead and say, right, well, if we're going to double it, then why do we double it now? Why do we have to wait 18 months to do it? And yet it didn't work out that way, because you had to have an evolutionary phenomenon. You had to go to the adjacent possible, in one way of putting it. And then much more recently, along comes Elizabeth Holmes and founds Theranos and says, you know what, I want to do the same for microfluidics, for blood testing. I want to disrupt this industry by showing that I can miniaturize the components. And it doesn't work. And the reason it doesn't work is because transistors are more efficient the smaller they get, whereas blood samples are less efficient the smaller they get. You don't get a sort of an efficiency gain that way. So you have to let 1,000 flowers bloom, to misquote Chairman Mao. You have to allow experimentation to take place and see what emerges from that, and see what it is that is capable of driving down cost in a particular industry, I think. So my book isn't really a how to do innovation policy. It's just a sort of survey of how it works, what does happen in real life. There aren't eureka moments to nearly anything like the extent we think. The apple did not fall on Newton's head, or if it did, he made the story up afterwards, etc. So it's a much more gradual phenomenon. It's a much more collaborative, collective phenomenon. It's a team sport, if you like. It's very slow to gather pace, but then very quick when it gets into its epidemic phase, a bit like a pandemic, perhaps. So, for example, there's a futurologist called Roy Amara writing in Silicon Valley in the 1960s who said that we underestimate the impact of new technology in the long run, but we overestimate it in the short run. And I think that's a very big insight. So, for example, I can find lots of quotes for you from people saying that home computers are a waste of time in the late 1970s, or saying that the internet is overrated in the late 1990s. When these technologies have appeared, but they're kind of disappointing, actually. They're not really achieving anything like you would expect them to. And then suddenly that becomes dramatically untrue a little bit later. So, for example, blockchain is a technology that we've come up with relatively recently. It's going to have a very small impact for a very long time and be very disappointing, I suspect. But perhaps in a decade or two, it will suddenly explode and change the world much quicker, much more than we think. I don't know if there are good pharmaceutical parallels with this. I'd be interested to know if this works in the pharmaceutical industry. And to some extent, pharmaceuticals are an interesting exception to some of the rules that I draw up. I mean, I'm very skeptical about the role of intellectual property in innovation generally. It isn't nearly as necessary, and it can be actually disincentivizing in a lot of areas. But of course, you do have to make something of an exception for drugs in that area.
Mm. So that's an interesting. So there's two things I want to come back to. The second one about pharmaceuticals. I think the first one is really, how do you know that things are going well, which is the big problem. Because if you look in retrospect at that was good, that it happened that way, and these were the things that led to it. How do you know on the way through that blockchain would be a great example. I think there's lots of people who are excited about it, but who don't know how to apply the technology to something useful. We might find in 20 years' time that it was. But of course, the problem of innovation management is that, which is, today, this year, our budgets are spent on things that may or may not be working, and we can't tell. Can we only judge in historically, or is there a way of prospectively looking at the value?
Well, that brings up another point that I'm fascinated by, which is the asymmetry over time of innovations. In retrospect, it's blindingly obvious that search engines were going to be invented in the early 1990s, and that they were going to transform our world, and that they were probably going to be the main way of making money out of the internet. At the time, did anyone see that coming? No, absolutely not. And yet, if Sergey Brin had never met Larry Page, do we think we wouldn't have search engines? No, of course not. Just like Thomas Edison was one of only 21 different people who came up with the light bulb around the same time. Some technologies are ripe. They're inevitable. They're going to happen. You can't stop them. Someone somewhere in the world is going to invent them. They're going to find their inventor rather than the other way around. And yet you don't see them coming. And I find this rather baffling. In retrospect, technological history can look blindingly obvious, but in prospect, not at all. And I don't quite understand why that is. I suppose it's complex systems are often like that. Things with emergent properties, which is what we're talking about. But on the whole, no, I wouldn't want to be in the business of predicting what's going to happen next. So, for example, I just made the case that we saw a lot of transport changes in the early 20th century, saw a lot of communication changes in the late 20th century. What's going to be the big theme of the first half of the 21st century? Well, we kind of think it's going to be communication and computing, don't we? But actually, I don't think it is. I suspect that biotech will overtake it and become more important. But there's no way that I can prove I'm right on that. There's a lot of serendipity involved.
Absolutely. And on serendipity, I mean, just to loop back to your observation about pharmaceuticals. So I interviewed Safi Bakul, the author of Loonshots, about a lot of pharmaceutical examples in there of, I'm going to say, serendipity, active pivoting, agility in the face of something interesting happening, but very poor adoption on the way through of some very interesting ideas like the statin class, which needed a kind of mad champion to keep it alive while it looked like it was going to fail on the way through.
Really?
Yeah.
Very interesting.
And I think that kind of linearity. Yeah, that kind of linearity that you describe, I think, there's a bunch of people who are very, very clever within the industry who are, linear, right? They want to predict, they want to forecast, they want to say what's going to win, what's not. But I've never seen any evidence that any of them are any good at that. So I'd be interested in whether that has a parallel in other industries or
not. Yes, I think so. I think it's a general feature of what we used to call in the evolutionary biology sense exaptation, that something is adapted to something that you didn't expect it to be adapted to. It's invented for one purpose, but then becomes very useful in another purpose. The whole history of computers and telephones and things like that is really one of surprising sort of detours taken and ending up somewhere else. I think generally. So yes, I do think that serendipity is important. It's probably more obvious actually in the pharmaceutical area than in some other areas. But just to give you one really lovely example of that, DNA fingerprinting, the ability to identify people from their polymorphisms in their DNA was stumbled upon almost literally by Alec Jeffreys at the University of Leicester in the 1980s. He just sort of noticed one day when he was doing a study of whales, I think, DNA samples from whales, that there was individuality. And he gave a talk about this. Local police heard about it and said, do you think we could use this as a form of identifying criminals? And they had a case they wanted to solve. They asked him about it, and they said, look, we've got this chap. He's admitted to a crime, and this is a sample from the crime scene. There's a very similar crime in the same place a few years ago. We think he must have done it, but he's not admitted to that one. Can you tell us if he did it? And Alec Jeffreys looked at the samples, did what is now standard DNA fingerprinting on them, and said the same person did both crimes, but it definitely wasn't the person you've arrested. They said, what? How can that be? He's confessed. Well, they eventually admitted they couldn't bring it to court because Jeffrey's evidence would be very unhelpful to them. So they asked all the men in the surrounding area to take a test, and they still didn't find the murderer. So they didn't know what to do. And at that point, somebody let slip to the police that he had taken the test on behalf of somebody else. They tracked down to somebody else. They tested him. They found he was the murderer, and he went to jail. And that's the very, very first forensic use of DNA. Now that came out of the blue. Alec Jeffreys thought he was doing he was just interested in identification. It hadn't occurred to him that this was going to be a hugely important forensic thing. And we all thought DNA sequencing was going to be about medicine. Turned out for the first 20 or 30 years of DNA, it was a much more important tool in identification and forensics than it was in medicine, arguably. Now that's changing.
Yeah, interesting. Yeah, I remember I studied genetics in the 80s, and remember not really understanding very much about where it was going to go.
Yes, exactly.
And not being very good at it as a result. But yeah, no, I think that that kind of that exaptation that you described, that kind of adjacent possible that you describe, I think needs a sort of prepared culture, whether it's a country, whether it's an organization, whether that kind of, this is an interesting unmet need for a technology that we've just seen. But a lot of people, I think, approach the invention as if it has a linear step forward to its, destiny, its destination. Your book, I think, from what I've read in summary, is really a bottom-up stories about innovation. Do you see that that kind of jump, that kind of hopeful monster approach to development?
Yes, I do. I think we're going to be surprised by some of the things that emerge in the next few decades, but I don't think we should overestimate that, because actually quite an awful lot of innovation is just very slight tinkering improvements on existing technologies. I think that part of the theme of my book actually is don't get hung up on the big disruptive things that you don't see coming, on the black swans. Be much more interested, in a way, in the inch by inch improvement in existing technologies that we can achieve great things with. So, for example, in materials or in electronics or in all those areas, the internet is evolving. It's a creature of human minds, but it's not. But it's not held. It's not held to a plan inside a single head. It's evolving under its own steam, as it were. We can't stop it, even if we wanted to. Social media is an unexpected thing, and the effect it's had on politics and society generally is completely unexpected, and in that sense serendipitous and not all good. But it's inevitable, and it's not finished yet. It's heading in another direction every few years. So I do like to see it very much as a sort of continuously evolving thing, technology and innovation. But towards the end of the book, I'm a little bit pessimistic. I talk about how despite the fact that innovation has delivered fantastic benefits in terms of reduction of poverty, in terms of living standards, in terms of making our lives more interesting, and in terms of our ability to tread more lightly on the surface of the planet, nonetheless, we actually live in a time when there's huge resistance to innovation, when actually lots of people do their best to stop innovations happening, either on behalf of big incumbent firms which don't want to be disrupted. Look at the way the pharmaceutical industry has, on the whole, resisted the introduction of vaping as a safer form of smoking, if you like, safer alternative to smoking. Now, this has always been the case. I go through the history of coffee in my book, which was an innovation in the 16th century, and it spread through Europe. And everywhere it went, it was resisted. It was banned. It was outlawed. Usually on behalf of the wine industry or the beer industry, who didn't want people sitting drinking rival products, but also on behalf of rulers who realized that the trouble with coffee is people sit together in coffee shops and start talking, and sooner or later they talk about why the ruler shouldn't be the ruler, and the ruler doesn't like that for some reason. So it was seen as a subversive thing. So there's always been resistance, but today the resistance is often extremely powerful and well-funded. And if you look at what companies are doing with the cash piles they make, they're not ploughing them back into innovation to the same degree that they should be and that they were a generation ago. There's not the turnover and there's not the success of startup firms that there was. Although we think we live in a time of rapid innovation, to some extent we're experiencing an innovation famine.
And it is interesting to look at that kind of top-down, because I think there's a lot of fear driving top-down resistance. The idea of the precautionary principle or a bunch of other things which, do lead very rapidly to changes in IP systems and other enablers of innovation. Do you see
genetic modification of crops as an example of an innovation that a whole continent, in this case Europe, decided to reject, even though we now know it had huge potential environmental benefits.
And human benefits. I mean, the number of people who've died from not allowing genetic modification of crops is phenomenal. So do you think that you will see the emergence of, do you think the US will continue to be where it is versus Europe versus the UK versus Asia?
Well, I think China is overtaking us quite rapidly as the most innovative economy. And when I say us, I mean the West. I think Europe is, on the whole, hamstrung by unhelpful regulation of the kind we've just been talking about. America is better placed, and things like fracking show that there's life in the old dog yet, as it were. America still knows how to do innovation. But if you look at what's happening in China, the rapid way in which consumers have changed their behavior, in which money has disappeared and they're not even using cards anymore. It's all electronic payments. You see very rapid changes happening in China. Now, can a regime that's basically run by a communist party keep the show on the road for a process that's as dependent on freedom as innovation? That worries me, and if we are going to rely on countries like China for innovation in the future, then I think there has to come a moment where it does become much more free as a society. In some ways, of course, entrepreneurs are quite free in China, as long as they don't annoy the Conservative Party. Sorry, not the Conservative, the Communist Party. Slip of the tongue there. As long as they don't annoy the Communist Party, then they're much more free to do what they want than they would be in this country, where there are lots of petty officials with petty regulations to enforce upon them. And so I think that's one of the reasons that China has been so innovative, is because below a certain layer of non-freedom, it is actually quite free for entrepreneurs. And that it would be nice. Innovation is a surprisingly geographically limited phenomenon in most of history. It's the Italian city-states, it's Abbasid Arabia, it's Song China, it's the Netherlands, it's Victorian Britain, it's California. Wherever it flares up as a bushfire, it's not everywhere. And if California is to pass its mantle as the most innovative place on earth to somewhere in Asia, then let's hope there is sufficient interest in letting entrepreneurs freely experiment, whether it's in China or possibly in India. I suspect India in the long run is going to be a source of great innovation, as it was a couple of thousand years ago.
Absolutely. I'm very aware that you have a very tight calendar today. If you could give me 1 minute on.
But let's just wrap up, and then thank you very much for the chance to talk about it.
No, I'd be keen to, can you tell us a little bit more about the book, when it's coming out, and how people
comes
can
out
find it?
in the middle of May, 14th of May in the UK, 19th of May in the US. It's called How Innovation Works, and I'm really excited about it, actually. I think it's one of the better books I've written. A lot of it consists of stories of innovations, from steam engines to search engines, from vaccines to vaping, telling the story of how they happened and letting the pattern of how it happens emerge. And I talk about failures of innovation too, fads, failures, and fakes, and things like that. So I've had quite fun writing it, and I really hope people are going to enjoy reading it. And my battery is almost out on my computer, so I suspect it's going to shut me down before I have a chance to say goodbye. But sorry about that.
No, I appreciate every minute that you give me. Matt, thank you so much. If people want to find you,
I'd love to talk to more about pharmaceutical innovation to you at some point. So let's meet up in person.
Let's do that. Matt, thank you so much.
Thank you.
Thank you.